Dear students, today I am going to explain you an interesting topic which is number system that have their very important role in computer science and electronics. The number system is defined as a writing system to represent the numbers in different ways, for which we are using different symbols and notations to represent numbers. There are mainly four types of number systems which are used in computer science. First is binary number system, second is octal number system, third is decimal number system, and fourth is hexadecimal number system. So let's discuss one by one these all different types of number systems. So first, what is binary number system? As you can see here, the binary number system, which is also called the base 2 number system, is a method of representing numbers that counts by using combinations of only numerals which are 0 and 1. Here, binary means is only 2. 2 means this type of number system can have only two types of numbers which will be covered with 0 and 1. If you take some examples for binary number systems, here you can see as first example is binary number system is 10011. Only digits 1 and 0 are showing here, and you can see here the base 2 is written that represents the binary number system. And in second example 1110011 and 0. So these whole digits are written in a form of binary numbers, and the subscript which is shows here 2 that represents the binary number system. So if anywhere you will see the numbers which are written in computers and having their subscript value that is 2, so you will say that this type of number is a binary number system. Now come to the next one. Second is octal number system. Here octal means is called 8. Means the octal number system, also called the base 8 number system, which is a method of representing numbers that counts by using combinations of only numerals from 0 to 7. If we count the numbers from 0 to 7, then 0, 1, 2, 3, 4, 5, 6, 7. Here total digits are 8. So this is called octal number systems. And how we can represent this type of number system, you can see in this example. Here is written 5307 and in subscript the value is 8 here. 8 will represent the octal number system. But the value how it could be a octal number system, because of it having the value of subscript as 8 and the digits which are written inside this are 5307. All four digits are belonging inside these 8 numbers. So we can say that this value that we are showing here as in a form of octal number system is a correct value. If you take another example, that is 34516, all these 5 digits are inside these octal number system having subscript value 8 here. It's an example of octal number system. Now come for third type of number system, which is decimal number system. Here deci means is 10. Means this type of number system can have their digits from 0 to 9. The decimal number system, also called the base 10 number system, which is a method of representing numbers that counts by using combinations of only numerals from 0 to 9. Just count these numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These all digits are having the counting as 10. It means that this is a decimal number system. If you take some examples for these, you can see here 1908. All these four digits are inside these numbers which are of decimal number system, and you can see here subscript value that is 10. So this whole value will show that this is an example of decimal number system. And here next number system is hexadecimal number system, where hexa means is 6 and deci means is 10. It means that total are here 16. So total is here 16. So hexadecimal number system is also called the base 16 number system, which is a method of representing numbers that counts by using combinations of only numerals from 0 to 15. Here, if we count numbers from 0 to 15, so the counting will be total as 16. That will come under the hexadecimal number system. So numbers will be from 0 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 9 we have not to write here 10, 11, 12 because these are having their 2 digits. So in place of 10, 11, 12, 13, 14, 15 we have to write here A, B, C, D, E, F. If you take some examples here like AD05, here A and D both are coming under this hexadecimal number system, and 05 these are also coming here in hexadecimal number system, and in suffix you can see here it's written here as 16. This is the base of the hexadecimal number system. If we take second example, that is 104E, it means that 104 here 1 0 and 4 these are coming under hexadecimal number system, and at last it's written E is also coming under hexadecimal number system, that is here. So it means that this whole number is written in a form of hexadecimal number, and the representing sign here is 16, that is having their suffix value. So these were the four types of number system in computer science and electronics. Now next is very important term, which is a conversion of number system. There are mainly two ways through which we can convert one number system into another. First is conversion by multiplication method, and second is conversion by division method. So when we talk about conversion by multiplication method, then there are three types of conversions will come here. Means that when we have to convert these three number systems like binary, octal, hexadecimal, and these all when we have to convert in a one form, that is decimal number system, then we have to use multiplication method. But when we have to convert decimal number system into any one of these three number systems, then we can use division method for the conversion of decimal number system into these number system. Now let's do conversion. First, that is conversion by multiplication method. So firstly we have to convert binary numbers which is having base 2 in a form of decimal numbers which is having base 10. So if we take example like this is an example of binary number system which is having the value 1011 and base is here 2, and we have to convert this into decimal number systems. So how we apply here multiplication method? Firstly, as you can see here, if we solve this, what digits are written here? 1011. These four digits we have to write in same sequence, and then we have to multiply all four digits with 2. Why we have to multiply with 2 all four digits? Because of here the base is what? 2, and after that we have to give the power to 2 from right to left. So first 2 will have the power 0, and second 2 will have the power 1, third 2 will have the power 2, and fourth 2 will have the power of 3. Now calculate these numbers. So first will come here 8. It means that 1 into 2 raised to the power 3, that will come as 8, and next is 0 to 2 to the power 2. So when we multiply 0 with any number, so answer is coming as 0 always. Now next 1 into 2 to raised to the power 1, so it will come as 2, and last is 1 into 2 to the power 0, that means the value of 2 raised to the power 0 is 1. So 1 into 1 is called here 1. Now get the sum for these numbers, that is called, that will come as 11, and we have to put this 11 number here, and we have to apply the base 10. So this whole will be the answer for the decimal number system. So first we have converted here from binary number system to decimal number system by using multiplication method. Now let's convert second one from octal number system having base 8, it is written 2, that is a mistake. So octal number system having base 8 into the form of decimal number system which is having the base 10. If you take example for this, that is 105, and base is here what? 8. This is an octal number system that we have to convert into the form of decimal number system. So we have to apply here same method, that is a multiplication method. So for this, here is 105 3 digits, so we have to write 105 in same sequence. After that we have to apply here multiplication with 8. Previously we have to multiply with 2, but here we have to apply multiplication with 8 because of here base is 8. 8 is for octal number system, and now we have to give the power to the 8 from right to left and starting from 0, that is 0. Next it will have the power 1. Next it will have the power that is 2. Now get the total for these numbers, that will come as 69, and write this 69 here and base 10. That means that we have converted octal number system into decimal number system. Now next is we have to convert hexadecimal number system having the base 16, that mistakenly written here. So hexadecimal number system having the base, and we have to convert this into decimal number system having base 10. Here we are taking example as 10f having the base 16, that we have to convert into the form of decimal number system. So same method, that is a multiplication method. Right here the digits in a same sequence, that is 1, 0 and f. Here you can see what is the base here, 16. So we will do multiplication these all three digits with 16, and we will have the power of 16 from right to left, that is 0, 1 and then 2. Now count the values. If there is 16 raised to the power 2, it means 16 into 16, that will come as 256, and 0 will multiply to any numbers, it will come as 0. And next is f, that will not be applied with 16 raised to the power 0. So f value, as we all know that f is having the value in hexadecimal number system, that is 15. So we have written here as 15, and 16 to the power here is 0. So here whole value is called 1. So we have multiplied here 15 into 1. Then 256 plus 15, the total will be 271. Now right here inside the brackets, that is 271, and right here the base value, that is 10. This is called decimal number system. So this we have also converted from hexadecimal number system to the decimal number system. Now we are coming for the next conversion, that is by division method. So first we have to convert here decimal number system which is having their base 10 into binary number system which is having their base 2. So if we are having the example like 11, then we are having the base 10 for decimal number, and this we have to convert into the form of binary numbers. So we will write here 11. Here we will divide this 11 by 2. Why will divide this? Because this is the second type of conversion by division method. So when we will divide this 11, so table will go for 5 times. It means 2 5s are 10, but 1 will be the remainder here. So we have to write 1 here. Now, so you can see here 2 to the 4. So here when we subtract 4 from 5, so remainder will be here 1. So we have to write here remainder 1. Now 2 1s are 2. There will not be any remainder. So we have to write here 0. Now 1 could not be divided by 2. Directly we have to shift this 1 here only. And now we have to write the sequence of these remainders from bottom to top, and we will write here 1 0 1 1. So 1 0 1 1, and this sequence we have to write inside the bracket here, that is 1 0 1 1, and we will write here as base 2. So means that this will be the answer of our binary number, that decimal number has been converted into binary number, that is the answer. Same as if you do next conversion from decimal number system to octal number system, then again same method, division method we have to apply here. So if you are taking example as 69 and base 10, that is for decimal number. So we have to write here 69, and this 69 we will divide by 8. Why? We will divide by 8 because this decimal number system we have to convert in a form of octal number system, and octal means is 8. So this decimal number will be divided by 8. So the table will go 8 times, that is 8 8 ja 64, and the remaining digit, that is 5, in a form of remainder we have to write here 5. Next 8 will be divided by 8 again, so 8 1 ja 8. So there will be no any remainder, so we have to write here 0, and this 1 could not be divided by 8, so 8 will be shift at bottom. And now write the sequence from bottom to top, that is 105 105, and I write this 105 here, and then write here base 8. This will be the answer of octal number system that has been converted from decimal number system. And at last we have to convert decimal number system having the base 10 into hexadecimal number system that is having their base 16. So if we take example of 271 of decimal number system that have to convert hexadecimal. So write here 271 and divide this number with 16 because we have to convert this decimal number system into hexadecimal number, that means is 16. So when 271 will be divided by 16, the table will go up to 16 times. It means that 16 into 16, that will come 256, and when we subtract 256 with 271, so remainder will be here as 15, and this 15, as you all know that we cannot write in hexadecimal numbers, this 15 will be converted into form of f, so we will write here f. Next, this 16 will be again divided by this 16. Now the table will go only one time. 16 1 the 16, and there will be no remainder, so we have to write here 0. And this one could not be divided by 16 again. Here 2 is written as mistakenly, so we have to write here 16. So this one will be shifted just bottom to these remainders, and we will write this in a sequence as in a form of 10f from bottom to top. This 10f we have to write here 10f and there in base, that is 16. This will be the answer of hexadecimal number which is converted from decimal number system. So this is our answer. Now finally I am going to tell you about binary calculations. The calculations that we will do here, that is addition, subtraction, multiplication and division. So let's come to the first, that is binary addition. So what are the rules to do binary additions? Here binary means is what? The numbers which are having only the digits 0 and 1. These two digits we will have all time, and the calculations that we will do here for addition, subtraction, multiplication and divisions, we will use only 0 and 1. We will not use any other digits because these binary digits are calculated by our computer system. So here if we take example like 100,101, and this we have to get the sum with 10100. If we have to get the total of these two numbers, so what are the rules to do the binary additions? So first rule is what? If we do 0 plus 0, then answer will come as 0. When we do 0 plus 1, that answer will be 1. When we do 1 plus 0, answer again will be 1. If we do 1 plus 1, then the answer will be 0 and it will have the carry 1. If we do 1 plus 1 plus 1 means 3 1 when will be added. So if 3 1 will come for the sum, so answer will be 1 and that will have their carry as 1. Now do calculations here. Now you can see here 1 plus 0, answer is 1. 0 plus 0, answer is 0. 1 plus 1, the answer will be here 0 and it will have the carry 1, and this carry will be shifted to the next, that you can see here, that is in red color. Now this 0 will be changed into 1. So now 1 plus 0, you can see the answer, that will be 1. Now 0 plus 1, the answer will be 1 and 1 is alone, so we have to write here 1. So now the answer will be here for these two binary numbers, that is 111001. This is the answer. Now next, let's do binary subtraction. This binary subtraction is having too much confusion when we are doing this type of subtraction or this calculation. So keep in mind, this can create confusion in your mind. So keep in mind what I am going to tell you, because this binary subtraction can give you too much confusion when you will do binary subtractions. But when you listen to me very carefully, that will be very easy for you all. So keep in mind what are the rules for binary subtractions. Let's discuss first one. That is the first rule. 0 minus 0, answer will come here 0. 1 minus 0, answer will be 1. And 1 minus 1, the answer will be 0. If we subtract 1 with 0, it couldn't possible to subtract this because negative value we cannot write here in binary subtraction directly. So this 0 minus 1 could not have any answer. But when we will give the carry to 0 from next significant bit, then the 0 minus 1 will have the answer 1. It means that when a 0 will take the carry from next, for example, this is 1 and this is 0. If this 0 will take the carry from next 1, so this 0 will become 1 0, and when we will subtract 1 from 1 0, the answer will be 1 here. This is the very important rule that we have to apply in this subtraction. Now let's do binary subtraction. So first is 1 minus 1, what will come here? 0, as we are having this rule. Now 0 minus 1, it could not possible to subtract 1 from 0. So 0 will take carry from next 0. It will take carry from next 0. That also will take carry from next 1. So this one will give the carry to next zeros. When 1 will give the carry to 0, so 0 will become what? 1 0, and 1 will become what? 0 now here. This 0 which have become 1 0, now 1 0 when give the carry to next 0. So next 0 will become as again 1 0, and this 1 0 will become as 1. Keep in mind this. When 1 0 give the carry, it will change in 1, but when 1 give the carry, it will change in 0. Now this 1 0 will give the carry to next 0. So next 0 will become as 1 0, and this 1 0 will become as again 1. Now subtract 1 with 1 0. So what will come here? 1 0 minus 1, as you can see here, that is 1. So answer is here 1. Now see at the top, 1 minus 1, that will be 0. See the top, 1 minus 1, that will be 0. Now at the top is what? 0. Now there is no any value that we have to subtract. So this 0 will come here directly, that is 0. And this 1 will also come directly here, so we will write here what? 1. Now our subtracted value is here, that is 1 0 0 0 1 0. This whole value is the answer for these two binary subtraction. Here you can also see the rules that I have written here for the binary subtractions. Means when one gives carry to next binary digit, binary number, that is 0, so then 0 will become as 1 0, and this 1 will become as 0. When 1 0 will give the carry to the next 0, then 0 will become as 1 0, and this 1 0 will become as 1 now. So these rules you have to remember, that will be very helpful when you will do binary subtractions. Now come to the next one, that is binary multiplication. If you have understood about binary addition or binary subtraction, then binary multiplication and binary division, that will be very easy for you all. If we will multiply here 1001 with 101, the multiplication will be the same as mathematical multiplication. So firstly we will multiply this one with all 4 digits. So 1 ones are 1, 1 0 0 1 0 0, and 1 1 the 1 again. Now second one, that is 0 here. Now multiply this 0 with these 4 digits. So 0 into 1 0, 0 into 0 0, 0 into 0 0, 0 into 1 0. So all will be 4 here 0. Now last is, that is 1. Multiply these 4 digits with this 1. Now 1 ones are 1, 1 0 0, 1 0 0, and 1 ones are 1. Now do the addition for all these three numbers. So first singlet is written here. Now 0 plus 0, that is 0. Now 0 0 and 1, that the answer is 1. Now 1 plus 0 plus 0, that is 1. Now 0 plus 0, that is 0. Now 1 is alone here, so we have to write here 1. So our answer for this multiplication is what? 1 0 1 1 0 1. This is binary multiplication. Now at last we have to do binary division. If we are having the value these like 1 1 1 1 1 0 1, and we have to divide these digits with 1 0 1, then divide same as mathematical division. So it will go one time. So write here 1 0 1, that you can see here, that is 1 0 1. 1 minus 1, that is 0. 1 minus 0, that is 1, and here 1 minus 1 is nothing, as you can see here, that is cross. Now next one will come here, this next one will come here. Now the value will become what? 101. Get the table of 101 again. That will go one times again and it will come here 101. These all three and these all three are same, so here will be nothing in their remainder. Now just write the value here, that is 1. So 1, this one could not be divided by 101, so write here 0 and take another value, that is 0 again. So now it will become what? 10. This 10 could not be again divided by 101, write here 0 and again put this one here. Now the value has become what? 101. So now 101 can be divided by 101, so it will go 1 times. So we have to write here 101 and the remainder will be here nothing. What? 0. So this whole division we have done here, and finally we have got what? The answer is 11001, means 110 and 1. This is the answer for this binary division. So the students, this was the complete explanation for number system and binary calculations and their conversion. So this topic is completely finished now. I hope you understood all about these, and next topic we will discuss later on. Have a good day.